Direct PLM is Focus PLM's solution to connect Aras Innovator and mechanical CADs such as Autocad, Bricscad, Solidworks, and all the other most popular modelers on the market. Let's see how it works, going through a few use cases. In the first use case, we will start handling this brand new file created in Solidworks inside Aras. To do so, we need to go through two additional steps. The first one is assigning part data to this document. This command relies upon Aras form for data entry. When data are confirmed, the connector renames automatically the file according to a configurable rule, and this file is now ready to be pushed into Aras by means of the Save into Aras command. This will actually create the part entity, a new CAD document associated with it, and will upload the file into the Aras vault. Let's check the result through the connector query on part tool. In this tool, you have on the left-hand side a search grid where you can specify any search criteria. And when you click on the resulting parts, you can see on the right-hand side all the related CAD and non-CAD documents. This is the part that we have just created, and it is currently linked to one single 3D document. The next natural step is adding a drawing. When I'm ready, I just need to click on Save into Aras. In the case of a drawing, I don't need to do any data entry because the system can retrieve all related information from the associated 3D. If we check now the situation in Aras, we can see that the part is actually associated to two CAD documents, the 3D document and the 2D drawing. For the 2D drawing, the connector has automatically generated a PDF viewable file, which can be seen embedded into the interface or can be opened into Acrobat Reader as an independent window. Next step, design reuse. Let's say that we want to create a new part similar to this one. For instance, I would like to modify this geometry, adding some kind of very evident slot, like this. Now I can use the clone command to generate a brand new part that's a clone of the original one. The command asks me if I want to clone also the associated drawing, and then I need to provide part data for this new part. But of course I can start from the metadata of the original part. So I need to provide a new part number, but I can reuse all other data, maybe modifying some of them if I wish. Clone will now generate the new part, a clone of the 3D object, the 2D drawing, and will set up all the needed relationships among them. So refreshing the query, we can now see that we have two different A-B parts, the original one and the cloned one, with its modified geometry. If we open the drawing, we can check that the title block was correctly updated to reflect the metadata for the cloned part. Last use case concerns assembly modification. We will start that from the Aras interface. Let's assume that as a designer, I've been assigned in Basket the execution of a step of an engineering change request. I can open the ECO object to get all the details about the change which I'm supposed to do. So I can get information about the change reason, the change description, possibly through an associated document. And directly from the ECO objects, I can access the impact matrix that specifies which affected items should be revised. In this case, I'm asked to modify this top-level assembly. One interesting point in Direct PLM connectors is that its commands are also available embedded directly into the Aras interface. So for instance, into this ECO form, I can select this CAD document and I can use the Direct PLM open command to open it inside Solidworks. I'm now ready to execute my changes. First of all, I need to lock the assembly, and then I can start doing changes. I can do that directly through CAD operations. For instance, I could just remove this sub-assembly, or I could insert another instance of this existing child. But I could also take advantage of the connector to support some operations. For instance, I could select one of the parts which I have created in the previous steps, and I can insert it inside the assembly. Or I could replace this sub-assembly with another alternative one available inside Aras, which I can search through the connector interface. And then I can use the replace command. Now I can save the resulting modified assembly into Aras. Saving the assembly also updates the bill of material for the associated part. We can check the impacts of these modifications into the bill of material using the BOM viewer command provided by the connector. In this interface, the bill of material is represented as a hierarchical tree, and with the same paradigm that we have seen before, when we click on one of the nodes, we can see on the right-hand side all the related documents. Looking at the BOM, we can spot some of the changes. For instance, this cover, this alternative cover is now used. But if I want to check all the changes I did, I can use the compare BOM tool that let me compare two different objects or two different revisions of the same objects. In this case, I'm comparing revision B, the current one of this assembly, with the previous one that was the starting point for the ECO. And we can see that changes are highlighted by colors. So green means added part, red means removed part, and yellow is used to highlight objects whose quantity has been modified. It's also possible to generate an Excel report out of this comparison. To complete my ECO tasks, I will probably need to update also the drawing. We can use these commands to directly open the related drawing. Then we just need to lock it and then save the drawing. And we are done. If you're interested in knowing more about the features of our Direct PLM connectors, don't hesitate to contact us at our email address info@focusplm.it.